See over here. This is 10 kilonewton per meter. The load is acting over here. This length is of 4 meter. So I will convert in terms of the equivalent point load acting at the CG. I will repeat, equivalent point load. Then this is nothing but 10 into 4 kilonewton per meter into meter is equal to 40 kilonewton. This is nothing but my equivalent point load. So what I find out the first equation, RA plus RB is equal to 40. This is the equations we achieve from sigma V is equal to 0. I think now students is easily understood how to convert the load in terms of the equivalent point load. Next one please. Now third equilibrium condition, sigma MA is equal to 0. We are taking the moment over here. I'd like to explain you over here right now problems. A point. I am taking sigma MA is equal to 0. RP. The reaction RA into 0, it is 0. This 10 kilonewton per meter, if it is converted in terms of equivalent point load, then it is 10 into 4, 40 kilonewton, creates moment in the clockwise direction. So plus sign, 10 into 4, this is my force, multiply by perpendicular distance 4 by 2, because the CG of load is at the center of load, minus, as it is created anticlockwise, RB into 4 is equal to 0. Let us we solve this one. So RB comes to be 20 kilonewton. Positive sign means upward. Now if we will put the value of RB in this slide over here, we will able to obtain, so RA plus 20 is equal to 40, and we will achieve RA is equal to 20 kilonewton. So like this way, using the three equilibrium conditions, we are able to achieve the unknown part, that is the reactions. Let us go ahead with the next one, problem number 5. Cantilever beam with the UDL 10 kilonewton per meter. Here this end is fixed, this end is free, and which has been converted in terms of the reactions forces shown over here. Let us solve over here. 10 kilonewton per meter. 3 reactions are generated. RAH, if this is my A joint, RAV and MA. Now applying first, sigma H is equal to 0. There is no horizontal force acting in this system, therefore HA is equal to 0. Now taking sigma V is equal to 0, RAV is upward. Now this total load acting downward, so downward is negative, 10 into the length, the given length is 2 meter, to 2 is equal to 0. So we will achieve RAV is equal to 20 kilonewton. Now applying the third condition, sigma moment at A is equal to 0. We are taking the moment over here at this point. So therefore RAH into 0, it is 0. RAV into 0, it is 0. But this MA is there, which I have assumed anticlockwise. So minus MA plus 10 into 2 into, now this is distributed in terms of equivalent point load, that is 10 into 2 acting at the CG distance, and this distance is 2 by 2 is equal to 0. So we will achieve, therefore MA is equal to 20 kilonewton into meter. So using this we will easily say that for cantilever beam we can also find out the unknown part using the 3 equilibrium conditions. The same thing will be noted over here. Next problem, overhanging beam with the UDL. Now please try to solve by yourself and check it out whether you got the answer or not. Using the first equilibrium equation, sigma h is equal to 0, definitely RAH is equal to 0. Applying second equation, sigma v is equal to 0. RAV plus RB is equal to total downward load 10 into length of beam, 4 plus 2, 6, 60 kilonewton. Next, taking sigma MA is equal to 0. Sigma MA means moment of all the forces acting at this point, at this junction is 0. In that case, RAH into 0 it is 0, RA into 0 it is 0. But this 10 into 6 total load, see over here, 10 into 6 into 6 by 2, because the whole load acting at the CG, center of gravity of the beam, 6 by 2 minus this RB. Why minus? Because this RB creates the anti-clockwise moment. RB into 4 is equal to 0. So by solving this equation, we found out RB is equal to 45 kilonewton, and by replacing this value in this equation, we can easily find out RB as 60 minus 45, that is the 15 kilonewton. So now we are able to find out these reactions with the help of equilibrium conditions, as these are the statically determinate beam. As we go to the next problem, number 7. Now let us combine the load on a simply supported beam and check it out what happens or how to find out the reaction. A simply supported beam, see, the length is of 5 meter. Here the 20 kilonewton load, here there is a mistake is there, it is purely kilonewton, not per meter length, it is kilonewton acting over here at the 1 meter, and the remaining 3 meter acting as a 10 kilonewton per meter, that is the UDL shown over here. RAH, RAV are the two component from the hinge support, and for the RB, that is the roller support, having the one reaction RB. Let us be applying the equilibrium condition. First, sigma h is equal to 0, definitely RAH is equal to 0, because all loads are vertical forces, there is no horizontal force acting, so RAH is equal to 0. Applying sigma v is equal to 0. Now please carefully see, RAV which is acting upward, minus 20 which is acting downward, minus 10 into 3, that is the UDL which is acting, plus RB which is equal to 0, and then we found out RAV plus RB is equal to 50 kilonewton. Next, sigma MA is equal to 0, we take a moment over here. So we taking moment over here, because of that the contribution of these two forces is coming to be 0. Next, 20, this 20 creates clockwise moment, so 20 into 1 plus sign. This 10 into 3 creates once again clockwise moment, which is acting at the CG of the UDL. So what is the perpendicular distance? Yes, 1 plus 1 plus 3 by 2 is the perpendicular distance for the UDL minus RB into 5 is equal to 0. If you want to understand, let us take simplest solution over here. This is a 10 kilonewton per meter. The equivalent point load which is acting over here, 10 into 3, 30 kilonewton. This is 20. So 20 into 1 creates a clockwise moment at A joint plus sign. Another load, this one, create a clockwise moment 10 into 3 into distance. I want this distance, 1 plus 1 plus 3 by 2. This is perpendicular distance. This is RB minus RB into 5, total distance. 3 plus 1 plus 1, 5 is equal to 0. Solving this, we will find out RB as 25 kilonewton. Please see the slides over here, please. So we found out RB as 25 kilonewton, and by putting this value RB in this equation, we easily found out RAV as 50 minus 25, that is 25 kilonewton. So I wish that remaining problems you will solve by yourself. See over here, problem number 8, UVL, simply supported beam. Please note down this beam in your notebook and try to solve by yourself. Find difficulty, please contact me through phone or maybe email. Convert it in terms of the equivalent point load, and then using the 3 equilibrium conditions, solve the problem. Next problem, problem number 9. Simply supported beam with the moment, concentrated moment acting at a point. How to solve? Using the 3 equilibrium conditions. See over here. Sigma V is 0, RAV plus RB is 0 because no force is acting, and then taking sigma MA equal to 0, we will able to find out the answer. Next, problem number 10. Loads to 1, 2 concentrated load plus UDL are acting, and we have to find out the reactions. Simplified figure and the solution over here. Next problem. UDL, overhanging beam is there, overhanging portion is there, UDL plus point load, and we will able to find out the solution. So now let us take some question answers. Can we say a beam with the 2 roller as a simply supported beam? Justify with the reason. Give the 2 practical example where each type of the support have the beam been used. See as many as practical examples in your life so that you will understand better way. Thank you. Is there any questions? Yes. So now